Hello everyone, I'm starting a new project in Unreal Engine 5 and I thought I would keep a devlog of my progress, issues, and decisions along the way. This will be a narrowly focused combat game with influences like Ghost of Tsushima, Sekiro, and the Batman Arkham series, as well as Hyperlight Drifter. The idea is for combat to require the player to think fast, choosing the correct actions to defend against enemy attacks. To maintain my sanity as features get added to the project, I need a foundation to be both flexible and modular. So today I thought I would talk about the very first thing I implement for most projects, and one of my favorite programming patterns, and that is the state machine. As features grow, character logic gets messy, and even if you're careful, if you don't have a systematic way of separating behavior, you can end up with spaghetti code. Input handling, animation flow, cooldowns, they all start tangling together. A great solution for this is a simple tag-driven state machine that owns small, focused state objects. Each state executes code upon entering, every time the component ticks, and upon exiting. This is the fundamental state machine pattern, but there are many ways to extend it to make life easier. I have also included virtual handle input and handle command functions that pass player input along to the state in case it is needed. Handle input passes continuous input data, while handle command passes discrete events like attack or jump. It uses gameplay tags, which makes it extremely flexible. A can-enter boolean function that'll check that the conditions for entering the desired state are met. This helps with, for example, if you implement a cooldown for your attack, can-enter will check whether this cooldown is active and reject entering if so. Since the states are created using new object, the state machine component is the outer for the state objects, and so their lifecycle is tied to the component. When the character is destroyed, the states are cleaned up by garbage collection. This makes the system leak-proof without manual memory management. Since the state machine itself is an actor component, this allows any actor to use this pattern. The base C++ logic is designed to work with any character, meaning that you can use it for the enemy AI as well. And it's also not too hard to transfer this code to a new project and implement it quickly. If you've not used a state machine pattern before, this will change your life. Implementing new behaviors becomes much simpler because you no longer have to rethink the how or where that is already established. You only have to think about the what. What exactly do you want to do? What should be done at the entry point? What, if anything, needs doing every tick? And what needs to happen right as you exit the state? The state machine component contains a map of gameplay tags to base states and a pointer that tracks what the current state is. When you switch from one state to another, the state machine exits the current state, enters the next one, which becomes the new current state, and starts ticking or updating the current state. Every state derives from the base state, and I've marked this class as blueprintable, which is where the real power lies. The advantage on the C++ side is I can implement heavy lifting like initialize, try switch state logic, and base variables in C++ for performance and strictness. The advantage on the blueprint side is that by inheriting from these C++ classes in blueprints, I can create multiple variations of the same logic. For example, a light attack and a heavy attack. They can both inherit from the same base melee attack C++ state class, sharing the same C++ combo logic but using different animation montages and damage values defined in the editor. Lifecycle methods like enter, tick, and exit are blueprint native events. If you don't know what this means, blueprint native event means I wrote the math in C++, but I do particles or sounds in blueprints. So I can write the core logic in C++ and decorate it with visual effects or sounds in blueprints. But I actually go beyond this. I like to craft most functionality in C++, but only use it in blueprint. If I can get away with it, often my classes are just a big toolbox with functions that are not called at all in C++ and only actually used in blueprint. This is a personal choice, but I like it because it makes code separation through modules easier. Two classes can know nothing about each other, lie in completely separate Unreal modules, and yet work well together because they interact through blueprint. The character that owns the component pushes input and commands to the current state. The character doesn't care how you move or attack, it just passes the intent to the state. So if the movement state cares about receiving the command light attack, then it will go ahead and execute whatever it is designed to do when it receives this command. In this case, it tells the state machine to go ahead and try and switch to the light attack state. In this melee light attack state, I have cast the owner of the state machine component as a BP player in the initialization event. So now I have access to everything in the player class. When the state enters, it immediately performs the attack, which consists of an animation montage. And in this case, I used timers to define when the attack state can be exited and when you can combo to stay in the attack state for a second attack. But this can be done with animation notify states as well, or any other way you can think of. That's the point. That's the power of this setup. It allows you to make any implementation choice you need for the specific problem you're trying to solve. One thing to keep in mind is your primary component tick group. You may want to use your state logic to update pre, during, post physics. There are many options for when to have your component tick. This is something you don't often need to concern yourself with, but if you find that strange things are happening a single frame before or after you expected, this is a good place to check. I once had a single animation frame delay that caused a very annoying twitch in a character just as they turned, and it turned out an event was triggering in the animation blueprint 1 frame later than I expected, simply because my state machine component was set to tick during physics. I changed this to pre-physics and the issue was fixed. So, do you have any thoughts or good resources for a state machine implementation out there that you would recommend? Any glaring problems with this setup that I have not considered yet? Feel free to comment below, and until next time.